believe it or not, this is the last week of the semester. So we have only one more week to finish the semester. Next week, the Thursday, the final exam is scheduled at 1:45 to 3:45. Okay, right? I think so. So 1:45 to 3:45 Thursday. Okay, and our classroom is here, but our exam will be located at the Dana 107. So do not confuse the location of the exam. We have the plenty of the room.
Dana 107, right?
107. Why don't you close the door? Why don't you close the door? I understand, but sometimes it's a hard to person. Okay. Today's topic is the I/O system, I/O management. But throughout the semester, I think we pretty much discussed many of the topics regarding to the I/O. So this is kind of the wrap up such I/O system. So which means it may not take a long time to complete chapter 13. Okay, before we start, is there anyone who coming from the other department other than the computer science or computer engineering? I think most of my students are from the computer science, either computer science or computer engineering. So I have a question. If you are asked, what will be the future of the computer science and computer engineering? This is a too general question. What will be the direction of the computer science and computer engineering? Is it mobile? Everything?
Yeah, almost everything.
Mobile? Do you believe that? Any other opinion? Quantum computing. That's also interesting. What is a quantum computing?
Matrix computing.
Matrix computing? It's not binary. Okay.
Also cloud.
Cloud. What is a cloud computing?
It's when you
It's a
don't
cloud
use,
outside.
right. when you don't use operating system and you don't use a powerful machine and you are just using another machine on the internet.
So because nowadays we have most of the computer is connected to each other. So what if we design depending on the request? Like this is the database computer system, but hour later the condition is changed. We need more web services. So depending on the requirement, what service it can be, the very flexible. That is cloud computing. Any other? What will be the direction of the future of computer science and computer engineering? That's very important when you are learning the computer science subject and computer engineering subject. What will be the future of my major? Right? Then you can, if you are looking for a job, you'd better find a job that provides a brighter future, right? If you take a job that is almost like the Windows XP repair service, nobody uses Windows XP, right? So what will be the future? Somebody said quantum computing, and one student suggested cloud computing, and also somebody mobile. Yeah, I think that currently mobile is the hot issue, and it determines the most of the platform and interface, everything. Even the Google recently changed their searching algorithm that fit to the mobile platform, right? Which means that if you have the website, that's usually ranked very top when you search the Google. But if you do not provide the mobile interface, your rank will be lower and lower. Anyone else? If I know the answer, probably I don't have to be here. But in my opinion, the future direction of the computer science and computer engineering is a human. Okay? Think about what is the objective of a computer. Life is easy. We try to think about any algorithm, the platform, any architecture that actually try to mimic what the human beings are doing. Okay? Also, it can help what human beings cannot do. So, like the very fast computation. To have them, we need a processor. And think about the algorithm, like the AI, artificial intelligence. It's an algorithm. We try to mimic what human brains are doing, such as the neural networks and whatever. What about the signal processing? Is based on the sound, how to recognize and such a thing, and how to enhance the quality of it, and vision. And the network is a kind of the communication between the human being and the person. Among the person, we'd like to communicate each other using the language. Similarly, we'd like to communicate each other using the computer. That is a network. Okay. Also, language itself is the computer language. So, if you are thinking about the future of the computer science, what are missing in terms of the human being? So, I think the most the missing part in computer science and computer engineering is meaning and semantic. In other words, computer is based on what? It's a binary operation, 0 or 1. So think about, even though I'm teaching the data mining, so somebody believes the data mining can solve most of the problem. So sometimes somebody say deep learning. Really deep learning? No, I don't think so. What computer can do right now is, computer, no matter what kind of computer you have, no matter what types of the algorithm you use, it can find most frequent pattern. If that is not pattern, if that is not frequently happen, computer cannot imagine, computer cannot create it. What about the human being? Probably we are doing the similar thing as computer is doing. Like when I was 3 years old, 4 years old, my mom told me that this is the apple. So I saw that this is the apple. And this is another apple, this is another apple. Then eventually I learned the round thing and the shiny, sometimes the red color or bluishy and a little bit spicy, but it's delicious. This is the apple. I have my own definition. I have trained, I have learned, right? Computer is doing the similar thing. We can train, but that is only based on frequency. If that happens a lot, then that is the knowledge, that is the pattern. But somebody too much believe computer can predict the real future of that. Even computer cannot predict the next hour weather. That's true. So in other words, when you are thinking about the future of the computer and computer science or computer engineering, there are a bunch of the missing part comparing to the human being versus the computer. Okay? So one missing part is the meaning and semantic. Absolutely any computer output, any computer system, any computer architecture, they cannot implement the meaning of or semantic of the concept. Okay? They can. That is the reason I focus on when you are doing the computer job or the computer science, computer language, all of them are based on what? Data structure. What about your human brain? Is it based on the data structure? No, absolutely not. Nobody knows yet the details, how your brain is learning and working. But computer is nothing but 0 or 1. Then we try to organize such as 0 and 1. Okay, that is the data structure, that is the algorithm. And you can find something frequent pattern of the 000, 001, 010, something like that. That is the knowledge in computer. Even though when you read the article from the Facebook or Twitter, so nowadays you can see a lot of the article regarding to the big data and the deep learning or the artificial intelligence or data mining. No, I don't think they can do what you imagine. It can do only the finding the frequent pattern. Okay, so that time the next step, next era, next generation. In terms of hardware, we have been improved a lot. The network speed and the clock speed of the processor and the memory size, even hardware, the hard disk drive, the battery life of the hard disk drive. Nowadays we can use we don't have to use such old style the hard disk drive. Instead we can use the SSD and other fast media. What about the algorithm and computer science? Not much. So, for example, when ever think about why Google return bunch of pages? When you type for example, I'm interested in the Apple. Okay? So, when I type the Apple, what will be returned? Probably the Apple computer stuff, because Google believe most of the people are interested in the Apple stuff, the Apple product, but I am interested in the food apple. Okay, I try to eat it, and I try to drink the apple juice, something like that. At that time, if Google can understand such an exact meaning, semantic of the question query, they don't have to return bunch of the pages, millions of pages. Instead, they will return exact answer. That will be better, right? Instead of the millions of, sometimes you need to search a different way, which means Google is not correct. Okay? If Google knows the answer, it will return exact page, exact answer. So, how can we address? So at that time, what we missed so far in computer system and computer science is the meaning of the data. That's very important. So that will be definitely that part of such a research started from big data and deep learning, but still some of the computer system algorithms still miss the importance of the meaning of them. So that is the reason we can find some clues from the Facebook or other social media. I'm not a big fan of the Facebook, but the Google really afraid of the growing size of the Facebook user. Nowadays, I heard that a little bit decreased, but why?
People spend more time on Facebook than on.
And they put their meaning of the life. Like yesterday, it was very delicious. The apple juice in the shop or the stop-in shop, something like that. I can post it. So when you search the apple, the same query on Facebook, Facebook knows the meaning of your life from the previous message. What friend from the friend? What community that you join, right? So that is the difference. If you type the same query on the Google cannot know until you join the Google Plus or and agree your sharing your privacy information. They cannot use it. So Google a little bit scared about such a meaning of the Facebook. So that is the different thing. So nowadays they're using but the problem is the Facebook data is so big and it's not like the relational database structure. So it's based on the graph something. So it's a different processing. So that is a reason the big data and NoSQL database are spotlighted recently. Because we can get something meaning of the data from the social media network. So why don't you think about such a thing? What will be the next step? It's the same thing, even the network and information or something, the developer, wherever you go, so far it has been improved a lot in hardware, especially the mobile device and network, wireless network. But the next generation will be such a mini or the semantic computing. But probably there might be the buffer time that focus on the big data or the deep learning or the data mining, and eventually the research goes to the something semantic or the meaning of the data. What about the multimedia data? Video and image. Also, another example of to find such a meaning of the data. If we have the huge amount of text information, sometimes the simple image is better to explain. However, the current, even though we apply the image processing algorithm, computer vision algorithm, it's very hard to find whether when I show the picture, whether this is the Statue of the Liberty and something other. Sometimes it's very hard. Okay, so still the image processing and the computer vision technique is still very low level processing. So to jump to the high level, the meaning of that, so there are a lot of opportunity. So in computer science and computer engineering, why don't you keep in your mind such a direction, future direction? It can be 20 years later, 30 years later, but that can be the direction of the computer. Okay. That is the reason that nowadays the deep learning and the big data has been highlighted. Okay, so today we are going to talk about the I/O system. As I said, throughout the semester we have seen many topics of the I/O system, the separately throughout the chapter 1 through 5. So in this chapter we will just wrap up or just gather the information into one chapter. Also, one more thing is, after I took the Tylenol, because I got a little bit cold, cough, and the fever, so sometimes I had the same problem in my previous class, the database system. So sometimes I don't understand what I'm saying. So please try to catch the point from my lecture. So Tylenol is too strong. So, but that's the fastest way to get over. I'm going to ask the GA to take over my lecture. Okay, so what is a basic operation in computer? Why do you need the computer anyway? Why do you need the computer? Okay? Gaming? Or to make the money? So think about the gaming, okay? When you are doing the PC game or the hardcore game or whatever, so sometimes you need the specialized computer, mostly graphic card. So you need a very expensive graphic card to play the game. Why do you need a separate graphic card for gaming? What is a graphic card?
If you have a GPU, you can work in parallel.
Parallel, which means you have a lot of operation to read the RGB value and to display very high resolution the graphic images. You want a better quality of the image when you play the game. But using the traditional processor, memory, and the hard disk drive, yes, you can do that, but it's slow because it requires a lot of I/O as well as the processing. So which means there are two main operations in computer system. One is process really computation. The CPU can compute the like the plus, minus, increment, decrement, okay, and move the data and shift the data. That's the operation. Another one is I/O. Where do you get such information? Eventually, you need to get such information from the file, even program, process. Where do you get such a program image? It's from the file. So two main parts, the operation by the processor and also I/O. Both of them are required for the CPU. I think that we'd better open the door. Why don't you open that door too? You can open that. And leave it open. Oh, that's another one, so you should not. Let's do another classroom. So there are two main operations. One is the processing, the computation. Another one is that mostly we have focused on such a processing part. That because of that we need a scheduler and sometimes algorithm. So in this chapter we will see how to make the efficient the I/O system that focus on the input and output. Okay. This is the typical structure for the I/O system. So this is the I/O devices. Through the bus, it can be connected. The typical computer architecture we eliminate that part. It has the processor. So we have the bus. Bus is the main, the highway to send the data and to receive the data. And also what is by the way, I/O device? It's not only for the hard disk drive, but also screen, monitor, mouse, touchpad, and any input and output device can be considered the I/O device. And all of these I/O device directly connect to the bus? No, because each I/O device send and receive the message. However, the message format are various. It's a different data structure. So we need something in the middle that can interpret, that can understand such a message that is called the controller. Okay, so each I/O device needs such a controller. Then this is the hardware. Okay, so in it something software. So such a program software needed for the controller is called device program. So long time ago when I purchased the new hard disk drive, I need to install the program for this controller because each and every manufacturer at the time has the different data structure, different message format. So we need to install the different the program. However, nowadays one of the trend in the I/O device is standardized. So they try to form a standard the data structure. So if you are using the following such a standard, you don't have to install it. And so, for example, graphic card, the graphic controller can handle such a monitor, and also the processor needed. Processor is kind of can be considered as the I/O devices, so that is the reason it needs the memory and the bridge controller. Also, such a keyboard or parallel port, serial port, their message format is very simple. Okay, comparing to the other graphic card or disk drive, the message format is very simple. So they are connected to the extension of the bus, then connected to the main bus. So that is the overall structure. What about the SCSI controller? SCSI controller is more complicated. So which means we cannot use such an extension or the ID disk controller. So it has usually to the power of n 60 the I/O devices, so 0 to 15, then they are connected to the SCSI controller. Then this is the typical the input and output bus structure. So in other words, it has the I/O hardware consists of the port. Okay, so connection point. So each one has the port. Okay, and bus is the main highway to send and receive the message. Sometimes it can form like the PCI bus has an expansion bus. This one has something other bus. It is called the daisy chain. So it can form connect to each other. Okay. And PCI, the expansion bus is usually used for the simple message format or the simpler device, and that doesn't require very high speed transfer rate. And we need a controller. This is the hardware, so that it's called sometimes the host adapter. So that has the kind of the interpreter between the device and your computer system. Also, it can receive the request from the operating system, then process once it is done and return to the operating system using the interrupt signal that we have seen in the beginning of the semester. That is the interrupt-based I/O. Okay. So each device has at least 4 registers. So because the controller itself is a hardware, so it is based on the, it looks like the one computer system. So it has the register information. Register is a storage to keep the data in and out. So it has the data in register, can receive the data, and the data out to send out the data. Okay, and status the register as well as the control register. There's at least 4 register information in the device. Okay. So mostly it has the first in, first out buffer size is 1 to 4 byte. Okay. We will see the details of the memory map I/O. Okay. So memory, so each device is actually defined in the memory. So instead of using the hardware, the register, they can use such a address information, I/O address range, so that this area will be in the memory. This area will be used for input and output of each device. So this is the memory map I/O. So you can send the data to this specific address, then processor can read the data. If there is an interrupt from the DMA controller, which means it can automatically access the information through that address. So that is called the memory map I/O. Then each operating each system actually specify the address for each I/O. Yes.
Do the device only write on the memory or also on the hard disk?
Not only hard disk include the hard disk will be connected in this case the hard disk controller. Okay. Then when the CPU reads the data, it will access this memory. Then this controller will send the data to this memory area. Okay. Then you can pick up. Main problem, these are not big problem because the message size is small. But what about the hard disk drive? Sometimes you read 1 gigabyte, 2 gigabyte data, the big file. So you need to use only in this case, what is the total size? So quite small. So 1 byte or the 4 byte maximum. So it requires a lot of I/O in the memory. So we will see the direct, without the going to the memory, you can directly access the data. So we will see the such an example later. Then, how does the host, the operating system, know that there is the I/O? So there is the status register here. It's a status register. So status register will be changed as 1, which means there is a data. So in other words, host the operating system keep checking such a register, the status register bit, whether this is turned on. Okay, if turned on, then you can read the data. The problem, you need to keep checking such a status register for each device driver. So that is the that is called the busy wait. So we have seen the same problem in the synchronization problem. So for the critical section, if we need to keep checking, that will cost sometimes 100% of the CPU resources. So that is the busy wait. So this the polling, the architecture may cause such a busy wait. So to address that problem, so we can use the interrupt-based I/O. Interrupt means instead of changing the bit of the status register, you can interrupt. You can inform to the operating system, I'm ready to send out the data. Then, if the operating system interrupt means, as the name implies, it's a stop. Okay, interrupted. So which means the operating system, the CPU is doing something job, it will be stopped, the interrupted. Then use the next one. How? And not use it. Process the next one. How? Using scheduler. Okay? We cannot guarantee such the interrupt. That will be the next one, depending on the policy of the scheduler. However, anyway, using the interrupt, so we can address the problem of the busy wait. Instead of changing the bit, we can interrupt the operating systems and the interrupt signal. That's already discussed in the chapter 2, chapter 3. Okay, so this slide also we have seen before. This is a CPU side, the host side, this is the I/O controller. Common thing, both of them are hardware. Okay, that require the read and write the information. So CPU is mostly the processing the instruction, but so it should be fed on by the I/O controller, the I/O devices. So first, if the CPU receives the operating system host receive the interrupt signal, then initiate the I/O, then the I/O controller will start the send a message or receive the message, and then it receive the data or send the data between I/O controller and the operating system. Then once this is done, or the other interrupt, then it will be resume another task. Okay, that is the interrupt based. And depending on the hardware, so Intel has their own. I think that you learned in the microprocessor class. I'm not very good at the hardware part, but this is the predefined the interrupt signal. Okay, as a vector. Vector means that this is the already in the B kind of between the function in the processor. So in case of the 0, that is the divide by 0 error. Okay, mostly the computer cannot handle such a divide by 0. So it's mostly the 0 and so on. Also, you can define your own interrupt signal. So that can be your own instruction. So for example, page 4 is a routine. So it's a kind of built-in function in your processor. Also, such an interrupt can be used for the exception. Okay, so like the terminate process or anything happen in your system. okay, hardware failure, then you can use the interrupt and inform to the your operating system. What about the multi-CPU, multi-core system? Each CPU has their own interrupt system. So if you request the job, but sometimes if you are using the SMP, symmetric massive processor, that logically is a one CPU. So your operating system will not separate for example, the CPU1 request the IO job, but it can be processed with the CPU2 may receive the job. So, but depending on the policy, operating system can make the dedicated CPU and IO device. But mostly the SMP does not care. That's the simple, easy way. If you dedicate such a CPU and process, that will be your programming level need to balance the job. It's the game. Looks like the soccer game. Right now is the European the soccer event, right? I know that because one of the project team in data mining, so they are doing I think one of they are the undergraduate team doing the UEFA, the event detection from the Twitter. Okay, that is a direct memory access. So the problem of the program I/O, which means the memory met I/O, which means you need to go through always the memory address buffer. So what if we had a huge amount of the message to read and write the data? So why don't we bypass such a memory part? So let's take a look at the slide. So this is a CPU. CPU has their own education, okay? And this is the hard disk line. Traditionally, when you read the data, you need to go to the disk, okay? And the CPU need to read the data from the memory buffer, right? So direct memory access is you ignore such a thing. Instead, there is another controller that's called the DMA. The interrupt controller. DMA, the interrupt controller receives such a interrupt signal, then it directly go to the memory, the specific buffer, the X address buffer you can put, or you can bypass such the address or registered information to speed up the data. So this is the direct memory access, the data transfer between. But we need such a specific controller also. Controller is always needed to transfer data through the bus. Okay? So you can read and read and write the data, and keep the counter by the total size of the data. Okay. Application. Operating system provide a very good the encapsulation. So which means the application level you don't have to know about the system call or whatever. So you can use the API to use the input and output operation from your application side. Also, your programming language, for example, provide such a input and output. So, for example, if you read the data, and if you write the data, you calculate the integer I, for example. Integer I, you do not specify the address or whatever, right? So your operating system provide such a data structure. And also, depending on the device, their input and output are varied. So for example, it can be the character by character, or sometimes block. Character by character is like if you send data message to the console, okay, it's a byte by byte. But if you read the data or write the data to the hard disk drive, it's a block by block, as we learned. When I was the administrator, so when I joined the first job, I have the mind. So our system team has three parts. So one is the operating system part and database part, and the third one is the middleware, the transaction server. At the time, transaction server is, I think a couple of times I mentioned about the three-tier architecture, right? The server side, client side, there is another one is the application side, application server side. Like the web application, it can transfer, assign the transaction control. So it's a middleware. So at the time, middleware was the very, very important new concept. So there's an administrator who managed that part. So my part was the database administrator, and another part, the manager from the another part is operating system. And suddenly, I think there's after 6 months, it's within a year, the manager actually would like to quit a job. Instead, he made the company who provide the multiple server console, which means one of the problem at that time to manage, we have the around the 30 to 40 database server, and total the 100 and 100 something the system. So which means at least the 50 or 60 different console. So console is not network based, it's directly connected using the serial cable. So what he developed is the one system and connect each server, then it's a unified console system. What he did is just a simple byte-to-byte program to send. So you know the serial cable has several pins, and they send the data. You need at maximum need 8 pins, the 1 bit by 1 bit to send. So he speed up to send receive the message then, and I don't know the name of the device. So for example, the 16, there are switch to change it. The 16. So input is the 16, the serial cable, and the output is just one to console. He actually developed that by himself, and the very basic programming. Then he started is the business. Then, but after that, I never heard about how's going on. So that is the block by block or the character by character terminal. Usually there is a byte by the byte the sender and receive the message. And also, for example, the hard disk drive, it can be sequential. For example, the tape, the magnetic tape, or the but the random mostly the other. Okay, so there's a kernel also support such a I/O structure is as encapsulation, which means the hardware part is hidden by the kernel or the system. Which means you don't have to know about the application part, you don't have to worry about. Instead, you can just use the API provided by your program language. That is the reason you may not realize such a thing. However, if you are interested in the system programming, I definitely suggest to learn about the hardware specification for each the controller. At least I think in your microprocessor class you have learned about the what is that? The parallel port, right? So then you can make a simple program, assembly program to print out the message through the LP port, right? So that's a simple example, but if you understand such a device controller, it's I think definitely the good for your system program. This is a I/O structure provided by kernel. We already see block for the characteristic. Okay. What about the network device? Okay. So any of the device connected through the network, the basic protocol is the socket program nowadays. So what is a socket program? It's a
web server.
web server is the client server is one of the example. So socket is like this one, right? If you have the same protocol input and output, so if you are implementing the socket program based on the TCP, what information do you need? The receiver need open the port, right? Then the sender need to know where the socket is located, host name, then or IP address. Then the which door is open, which port is open, port number. Then the authentication, username and password, then you can connect. So using that, the socket program, socket interface, so we can implement the network device also. So, another type of the clock, the input and output device is the clock and timer. Actually, there is a critical in the hardware, not only hardware but software, how much accuracy beside the clock time you have. Okay, there might be different. This is one common mistake that when I have the new algorithm for scheduling. Scheduling? Okay, scheduling. So my scheduler is very fast, whatever. But anyway, faster. I'd like to compete with how much faster my algorithm is. So how can we judge whether my algorithm is the fast one? The stopwatch? Well, what clock? So that is the problem. Sometimes it makes sense, the word clock, if we learn only if you can learn your program only. But that doesn't make sense, because you have to operate at least the operating system to run your application program. So the type of the clock is elapsed time, only CPU time. Okay, so you can count the CPU time. However, in the CPU time, as you have seen in the chapter 2 or chapter 1, there are two modes: the user mode and kernel mode. So user time and system time. So even the system time, you need to consider what will be measured. So they provide the different time, operating system provide different time, kernel time and elapsed time, and timer of the CPU time. So when you think, no, I do not have the virtual machine here. So if you are using the Linux or the Unix system, you can type the time, then you can see time and run the application. Then it will show the three different times. Then you can see what is the wake clock time, what is the elapsed time, what is the timer of your CPU. Okay. Do you know what is the default time of the Unix system? The 1970.
They did.
Yes.
Right.
That is the first time that the Unix the system was invented. So I have seen some program used such the default time. So 1970, January 1st, January. So when I check the elapsed time, it is 30 years old, 40 years old running the program. And also sometimes if you have the out of battery of your BIOS, your computer system, the BIOS will be set up as the default time. So 1970. So there are two different main types of the I/O. One is the non-blocking and asynchronous. We already seen this one. Let's take a look at this slide that explains the non-blocking and the synchronous and asynchronous. As you can imagine, synchronous means that you need to get the response, then send the next the data message, and the next data message. So you can keep the order of the data message and receive it. On the other hand, the asynchronous is, this is a time, so you can keep sending the data, request and get the data, but we cannot guarantee order of the requesting the message. It can be the change, but the user side are responsible for to order such a message using address or the block ID and so on. Just like the other synchronous and asynchronous, synchronous is the better performance, but you may have the overhead to get this one to organize the data, or you may lose the data. On the other hand, synchronous, you can guarantee the data. If you do not receive the data, you can keep asking to receive the data in case of something fails. Okay, today I'm going to stop here, and I cannot continue, but fortunately we had 20 more pages, so I'd like to stop. So I need to take a rest for evening class or so. But